Hello, welcome to class. Today we'll be solving questions for AS11 past papers on quadratics. Okay, so with our knowledge and idea of quadratics, we'll be applying to solving past papers for today. For example, we have this question here: by using a suitable substitution, solve the equation of 2x minus 3 squared minus 4 divided by 2x minus 3 squared minus 3 equals to 0. So when we are asked to substitute, the value of the substituting, I have 2x minus 3 squared as A. You can use any alphabet of your choice. So I decided to choose A for that. That means where I have that, I will have A minus 4 over A minus 3 equals to 0. So looking for the LCM of this is A. So I have A divided by 1, which is A times A will give me A squared, minus A divided by A is 1 times 4 is 4, minus A divided by 1 is A times 3 is 3A equals to 0. So cross multiply this, I will have A squared minus 4 minus 3A equals to 0. Is that okay? So here I can use my quadratic formula of minus B plus minus B squared minus 4AC over 2A. Or I do the factorization method, which gives me, because I have to rearrange this because my A squared 3A has to be here minus 4 equals to 0. So factorizing this, I have 4A squared. Okay, so the factors of 4A squared are 1A and 4A and 2A and 2A. So the two numbers will give me this 3 is these two numbers here. Okay, so we have this. I'll substitute it into the value here, which gives me A squared plus 1A minus 4A minus 4 equals to 0. Group them. That gives us A into A plus 1 minus 4 into A plus 1 equals to 0. So we have our values as A minus 4 equals to 0 or A plus 1 equals to 0. So A is equals to 0 plus 4, which is 4, or A is equals to minus 1. These are our values for A. Remember, we substituted the value of 2x minus 3 squared as A. 2x minus 3 squared is equals to what? A. I've gotten the values of A, which we have 2x minus 3 squared as 4. So this I will just have to look for the square root here, square root of both sides, that is 4, which gives 2x minus 3 equals to square root of 4 is a positive or a negative 4. So 2x so we have 2x minus 3 is equals to plus or minus 2. And this, which is 2x minus 3 is equals to plus or minus, so that means 2x equals to plus or minus 2. 3 crosses to the other side to give us positive 3. So we have 2x plus 2 plus 3 gives us positive 5. That means x is equals to 5 divided by 2. Or minus 2 plus 3, which is the other value, give us 1. X will also give us 1 over 2. So the values of x is 5 over 2 or 1 over 2. So this is how you go about solving your quadratic equation. Let's move to the next question here. A line has equation y equals to 3x plus k, and a curve has equation y equals to x squared plus kx plus 6, where k is a constant. We are asked to find the set of values of k for which the line and curve has two distinct points of intersection. So I'll bring these two equations. We have y equals to 3x plus k, and the other y equals x squared plus kx plus 6. So bringing both equations, 3x plus k, will give us x squared plus kx plus 6. So this is what we have. I'll bring the two equations together, moving this to the other side here. I have x squared plus kx plus 6 minus 3x minus k equals to 0. So we have x squared plus kx. I'm rearranging minus 3x plus 6 minus k equals to 0. Here I factorize this expression to give me x squared plus what is common there is x. I have k minus 2 plus 6 minus k equals to 0. So using my quadratic formula of b squared minus 4ac, where my b is this guy here, and this is my c, and this is my a. So the coefficient of b there is k minus 3 squared minus, we have 4, a is 1, and our c is 6 minus k. Okay, so this is what we have. So expanding this, I have k minus 3 into k minus 3. This gives k squared minus 3k minus 3k plus 9. This gives us k squared minus 6k plus 9. And moving to the other equation, I have minus 4 times 6. That gives me minus 24. And minus 4 times k gives us plus 4k. So I bring these two equations together, which gives me 0. So resolving this, I have k squared minus 6k plus 4k will give us minus 2k. This is this guy here, minus 6k plus 4k giving me minus 2k. Then I have positive 9 here, minus 24 will give a negative 15. And so this is equals to 0. I will factorize. You can use your quadratic formula b squared b minus b plus minus b squared minus 4ac. So using this, I have 15k squared minus 15. So the factors of minus 15 is either plus 3k or 3k and minus 5k, or I have minus 1k and 16k, or the reverse. So this I will have k squared plus 3k minus 5k minus 15 equals to 0. Factorizing this equation gives k plus 3 minus 5 into k plus 3 equals to 0. So what do we have? I have k plus 3 equals to 0. K is equals to minus 3. Or k minus 5 equals to 0. K is equals to what? Positive 5. So this is the value for k in the given equation above. So we are asked to find a set of values for k that has two distinct points of intersection. So this is how you go about it, solving this equation. We move to the next question. And this, here we have the equation of the curve. It's y equals to 2k minus 3s squared equals to kx minus k minus 2a. K is a constant, the line y equals to 3s minus 4 is a tangent to the curve. So we have y equals to 3x minus 4. We move this equation just the same way we did for the up one, 2k minus 3, okay, into x squared minus kx minus k minus 2 equals what? 3x minus 4. So this is what we have for this equation. So I can, bringing them together, I have 2k minus 3 s squared minus kx minus k minus 2 minus 3x plus 4 equals to 0. So we have 2k minus 3 x squared minus kx . minus 3x. Opening this bracket, I'll have minus k plus 2 plus 4 equals 0. We have 2k minus 3x squared minus, so I'll factorize this. I have k minus 3. Okay, that becomes k plus 3. Then we have minus k plus 6 equals to 0. Using our quadratic formula, b squared minus 4ac. Our b is k plus 3 squared minus 4. A is 2k minus 3. And c is what? Minus k plus 6. So this is what we have for this equation here. We go ahead to factorize k plus 3 squared. Expand this. This gives k squared plus 3k plus 3k plus 9. We have k squared plus 6k plus 9. Opening this bracket gives me minus 8k plus 12. So I bring minus 8k plus 12. Wait, this has to be expanded with the rest because this is 4 multiplied by 80. So I will expand these guys first. Okay, so to make it easier, we have 2k multiplied by minus k will give us, please leave the 4 outside. So we expand the two functions. Then 2k multiplied by that will give us minus 2k squared. Then 2k multiplied by 6 gives us 12k. And we have plus 3k and minus 3 to that gives me minus 18. We have k squared plus 6k plus 9 minus 4 minus 2k gives me plus 8k squared. Minus 4 times this gives minus 60k. Then we have plus 72. So collect like terms, I have k squared plus 8k squared plus 6k minus 60k plus 9 plus 72. So this gives 8k squared plus 8k squared gives 9k squared. I have 9k squared plus 6k minus 60 gives minus 54k plus 9 plus 72 gives plus 81. So we can factorize, we can simply reduce this. I will divide 2 by 9 by 9 by 9. So this gives me k squared minus 6k plus 9. So this makes the work easier for you by dividing 2 by 9. So I can simply factorize this. Or you use your quadratic formula. I have 9k squared with factors of 9 are 3k and 3k. Okay? Or 1k and 9k. And 3k will give me 6. So simply I'm using k squared minus 3k minus 3k plus 9. Factorizing this, I have k into k minus 3 minus 3 into k minus 3. So you can see we have two values, similar value k minus 3 and k minus 3. So we say k minus 3 is equals to 0. That gives us k as 3. So the values of k become 3. So we have solved this equation. It is very easy. So just you have to keep your mind to it. It's not hard, so study and apply your knowledge to solving more questions. So let's move ahead to same quadratics. In this, we are expected to express 16x squared minus 24x plus 10 in the form of 4x plus a squared plus b. In this, you are going to be using what we call completing the square method. So when you see any quadratics like this, please don't use your quadratic formula, don't use factorization. If you are asked to express in this form, use your are completing the square method. And if you remember you're completing the square method, the first thing you have to take note of, the coefficient of x squared. If your x squared has no coefficient, you can move ahead to divide the coefficient of x by 2. But in this instance here, we have our x squared having a coefficient, which is 16. So we have to divide first by 16 before we go ahead to divide by our 2. So in this, I will have 16x squared, this is my equation, minus 24x plus 10. So the first thing we do is divide through by the coefficient of x squared. But if there's no coefficient of x squared, you can move ahead to the next step. So this gives me x squared minus 24x divided by this. I'm breaking down. 8 can go here 2, 8 can go here 3 times. So this gives me 3 over 2x. 10 over 16, I can leave it as 10 over 16. I can still break it down. So I will decide to move it to the other side to give me minus 10 over 16. So this is what we have here. So having this gives us x squared minus 3 over 2x. Remember, in completing the square, you have to divide the coefficient of x by 2. So I divide this by 2, which is equal to minus 10 over 16. So dividing this by 2 will give me x squared minus what? 3 over 4, which we can factorize as x minus 3 over 4 squared equals to what? Minus 10 over 16. And if you remember clearly, so whatever you add to this side of your, whatever you have in this answer here should be added to the right-hand side of your equation. So I'll move plus 3 over 4 squared here. So this gives x minus 3 over 4 squared equals to minus 10 over 16 plus 9 over 16. So looking for the LCM of this gives 16. I have minus 10 plus what? 9. So we have x minus 3 over 4 squared is equals to minus 1 over 16. So if I have to look for the square root of this, I have 1 over 4. So this gave me x minus 3 over 4 squared as 1 over 4. So bringing it to the other side, this gives x minus 3 over 4 squared plus 1 over 4. I want to multiply all through by 4. So this gives 4x minus 3. Remember, our question says in the form of this plus 1. So this is what we have as our answer for this equation. It's easy. This is using complete. So this is the answer for our equation. Let's move to the next part of the equation. Given that the equation 16 x squared minus 4x plus 10 equals to k, where k is a constant. So we are using that part of the equation we have as 4x minus 3 squared plus 1, 4x minus 3 squared plus 1. So we have that as equals to 0. That means I have 4x minus 3 squared equals to what? Negative 1. I'm looking for this. We can have our 4x minus 3 so we can have 4x minus 3 is equals to what? 0 on this, because this does not have a root. So we are saying when the root is only one root, I'm making that 0. So that gives me 4x equals to 0 plus 3. 4x equals to what? 3. So x is equals to 3 divided by 4, which gives us 0.75. So this is where k is a constant and it has exactly one root. So we are finding representing the value of this because using this equation, there's no root for -1. So we have this as the answer for the solution to this question. And then let's move ahead. We have more questions to solve. There are more past papers. Please find as much as you can to solve on your own. So we have this equation of the line is y equals to mx plus c. Here m and c are constants, and the equation of the curve is xy equals to what? 16. So how do we go about this? You are asked to, given that the line is a tangent to the curve, express m in terms of c. So we have mx plus c equals to y. For the second equation, I have xy equals to what? 16. Simply, I can make x there or y equals to what? 16 over y, or it's easier you make y as 16 divided by x. So I can have mx plus c equals to what? 16 divided by x. We have, when you first multiply here, I have mx squared plus xc equals to 16. This gives ms squared plus xc minus 16 equals to 0. So applying your quadratics, you can have b squared minus 4ac on this, where our b is the c value here. So we have our a as m, and we have this is a, this is b, and this is c. And we have b squared, that gives us c squared minus 4 times m times minus 16. We have c squared minus 64m equals to 0. So that gives us c squared is equals to what? 64m. Take note, our question says we should resolve in the form of what? M. To make m the subject of the formula. So that gives us m as what? C squared divided by 64. I'll go back to this point here. I think there was, we were supposed to have minus here. I'll change this to positive. So that means this becomes negative. So we have this. Okay, so please be careful of the sign, because without the sign, your answer might be wrong. So we have m equals to minus c squared divided by 64. So this is all. Please, there are more questions for you. I said they are giving that instead of n equals to -4, you can use that to find the value of the two distinct points. The value of c if n is equals to -4, so you bring in that equation where m is equals to -c over 64. So how do we find